Hey guys, this is Soil Hildebrand from 47874J Occam's Chainsaw, and today we're going to give a little explanation of our two-motor intake to lift PTO. So, starting off in the back, we have our two motors. We have one here and one here. Both of them go into powering this one axle that is double chained up to the top. The reason it's double chained is because when it was on one chain, the pressure tension of the lift caused it to snap, but the two chains disperses the weight. In terms of this piece of polycarb right here, that just helps our hooks from our claw just slide easily over without getting caught on that axle. Hopefully in a future design, we can move this axle down further so we don't have to have this because it just adds a little bit extra resistance. Now up at the top, we have this high strength axle here that goes all the way through to over here, and this axle is powering the intake, which is spinning at 600 RPM. Oh, I didn't mention, these two are blue motors, so this is all spinning at 600 RPM. And then over here we have this little 12-tooth gear. Now this 12-tooth gear is the gear that's moving. Let's see if I can get a better angle. So right over here, this little like one piece of C-channel I cut out, moves the gear back and forth from this piston. So the piston pushes the piece of metal, and the metal pushes the gear into this 36-tooth gear. So this 36-tooth gear, I'll talk about the crowns on it in a sec, but from that 36-tooth gear that goes through this whole axle, there is another pair of 12-tooth gears, and those 12-tooth gears then gear into another 60-tooth gear. And then from that 60-tooth gear, it's straight onto the lift. So I don't remember exactly what the final ratio is, but the intake's spinning at 600 RPM, and it's a 1:25 ratio down to the lift. So it's geared down twice. So the cool thing about this is, let's see, this axle, this axle, and this axle form an equilateral triangle. And that's basically what allows this whole thing to work. Because before we used to have a 36-tooth gear on this axle, which would go straight into here. But with that, it either made our intake way too slow or our lift way too fast. So being able to keep these two axles in the same spot, but add this third axle over here, is what allowed us to get the perfect speed for both of them. Now, you might notice that we have this little standoff and these crowns here. So the point of that is so when we lift up the lift, it'll stay in place. So on the controller, we have these two buttons operate the intake. And then for the lift, we have these two paddles down here. We actually have no button for the PTO. We just have it so that when our driver presses these two buttons, it'll engage the PTO and then spin the same motors as the intake. So if I press those buttons, we can see the lift will go up. But then so on here, let me show you here. Now, this is the picture of the PTO engaged. You can see the gear. You can see the gear is now meshing with the 60-tooth gear, and the standoff is out of the nuts. But if I press the intake button, you can see it drops a little bit, but the lift actually stays in place at this higher position, even though it's not being powered by anything, because this standoff locks with the crown gear. I'll shoot the shadows. Let's see, is it better here? The standoff will lock with the crown gear as this gear tries to push forward on it, but it just won't move, which helps us keep this lift up in case we ever need to drive around with the lift up. And yeah, that's about it for this system.